Thank you, Ammar. You guys can see my screen, right?
We can see your screen. Please try to stick to the 5 minutes. Appreciate it. Thank you so much.
Okay, thank you. Thank you. I'll try to be as fast as possible and precise. I'm Dr. Zafar. I'll be talking today about my area, which is nanofluids. It's more towards, you can say, thermofluids for heat transfer, and to see its application towards the sustainability. This is our university in case. I mean, we are in a desert region, but we are trying to focus more towards renewables, so it's more green in these areas. I'll be talking about nanofluids. In short, I'll give you a brief introduction. What is nanofluids? So nano is the nanometer range where we take nanoparticle at a nano 10 raised to minus 9 level. So the surface area becomes larger. It improves its thermophysical properties, mainly thermal conductivity, and in certain cases, viscosity, for example, if you're using them in lubricants. And this results in giving you overall better heat transfer. The idea is if you can increase the thermal conductivity, which will result in increasing the heat transfer of a system, this could result in reducing the size of existing system and also giving you better efficiency overall. So these are the different kind of nanoparticles. They exist in 1 dimension, 0 dimension, 2 dimension, bulk, graphene. You guys would have heard a lot about it, nanotubes, metal oxides. So these basically, we mix them in the conventional working fluid, such as you can call it water, you can have ethylene glycol, you can have engine oil, anything. Depends on the stability. And then you try to get as stable as possible, because the main idea is if you can mix this within a solution and liquid to make it as one, not suspended in a way that it does not sediment, it does not aggregate at the base like you see in here. We want it to be like this, along with a shelf life, to have a longer shelf life so that it could move towards industry and application. Nanofluids have various applications. I'll be showing you more after the slide. It could be used in aerospace for heat transfer, for example, the wicks and the sinks. It is used in, it has a potential, or we have done several papers where it could be used for nuclear reactors in terms of cooling water-based. It could be used in automotive radiators and automotive engines. It can be used for cooling of electrons, because with times, everything is becoming quick. So when things are becoming quick and faster, the system needs to be faster. And when that happens, you have a lot of heat being generated. So how can we reduce these heat? So nanofluids could play a role in that. You have in the refrigeration system, such as nano refrigerants or nano lubricants, which can increase the overall COP, therefore giving you better efficiency of a system. And this has a direct impact, again, on the cost, as well as the sizing of a system and also the emissions. It is also being used a lot in drug delivery, and as well in solar energy, which is one of the main area that I work in. So the idea in here is we try to work on technologies both. For example, if you want to increase the heat transfer of a certain element, it should be both on the direction of the metals. For example, if you have a pipe, so extended surface of that pipe, as well as the liquid that is going in. So we work on both. One such example is a patent that we recently did on photovoltaics. So what we did is we created a mist system below this, because in UAE, those who are not around or those who live in here would know that you can see the temperature rises up to 80 degrees on the PV panels on the front and back. And this high rise in temperature results in dropping your efficiency. So when we do the mist system, we end up reducing the back and front temperature of PV panels down to below 50 and 40, which means a reduction of about 34 degrees. This results in giving you better power. So that is one part. Another thing is using nanofluids for them. So instead of water, we mix nanoparticles with water, which means we can reduce this bar even lower. And the lower the temperature goes, the better overall performances. This is the idea of how we make the nanofluids. You take the nanoparticles, you suspend, put them in the base fluid. Of course, there is an optimum. Then you prepare them using different methods, 1-step or 2-step. And then you get different nanofluids. This is an example of a heat sink where you put it. And the expected results, as based on research, is mostly positive. We have another criteria where we can measure if what we are doing these nanofluids and extended surfaces and taking into account the pumping power, the pressure drop, if we add such nanoparticles, would this increase or decrease? So we have a criteria known as performance evaluation criteria, where we can evaluate this and see if what we are doing is beneficial in terms of emission, in terms of money, in terms of payback, and mostly using nanofluid has been successful in here. This is another area where we use nanofluids with lubricants. For example, we try to see the contact angle and surface tension. And the application of this later leads towards, for example, minimum quality lubrication, where you have a lot of grinding, cutting tools in aerospace application, for example, titanium alloys, nickel-based alloys. So when you do grinding and cutting of these device, for example, instrument, the easy idea would be given in here. So this is without a coolant when you do grinding, for example, working on a piece. And this is with a minimum quality lubricant coolant. And this is when you apply nanoparticle minimum quality lubricant. You can see clearly that it helps in reducing the wear and tear, improving the performance, and even the lifetime of the cutting tools that you're using. So this is just one example. We have several papers on these that gives you overall more details if you are interested. For example, this piece that is being worked in here is carbon fiber reinforced polymer, and we try to see how the impact of nanoparticle increases when you add it to the lubricant. So again, an area which needs to eventually move towards industry, currently mostly worked in research area, in labs, and a lot of success has been shown. So the next step would be how can we move the nanoparticle minimum quality lubricants into the industry to have a better impact. This is another area where we have the, you can see this is a diamond grinding ball and you have a carbon fiber reinforced polymer. So the idea is you spray the lubricant on here, you do with and without. So the results are shown here. So you can see if you use the lubricant, which is just dry, or you use the dry method on the carbon fiber reinforced polymer, the friction coefficient is very high. However, if you use carbon nanotube, which is the green line, you can see it reduces the friction a lot, which means this will give you better cutting, grinding, and even better surface finish.